How does artificial selection work without inbreeding? Since the invention of animal husbandry, humans have been selectively breeding animals and plants for positive traits like woollier sheep, stronger horses, etc. However, dog breeds, for example, often have many genetic problems due to inbreeding, and inevitably any kind of selective breeding is going to narrow the genetic diversity. My question is, how then do we have all those cows, sheep, goats, etc. with the positive traits, but without the genetic diseases and lesser overall health? And does this also apply to plants? Plants we tend to clone, especially when it comes to fruit trees. The banana industry is having something of a crisis right now because there is a disease wiping out banana trees. Since they are all clones, all of them are vulnerable to the disease. Dog breeding is interesting because we value the breed more than we value the traits of the dog. Because of this, there is a lot of inbreeding to keep the breed pure enough for show. Livestock, on the other hand, is bred for traits, like meat amount or dairy production. We don't care so much about pedigree in livestock vs their value as food. Farmers crossbreed cows all the time to get more milk or meat out of them. This keeps the gene pool moving. Also, livestock are not really that healthy. I worked on a farm training dogs for some time, and losing animals to disease is a part of doing business. A lot of animals don't live long enough, especially meat animals, for genetic abnormalities to become an issue. Breeding animals are generally vetted more, but not always. While inbreeding in a farm setting has caused problems, overall there is enough population that it isn't necessarily an issue. Every human has a lot of what most would consider to be inbreeding, in that same sense in their genetic tree. As world populations used to be much smaller, and people didn't have cars to travel. In just a few generations, your family tree consists of many people, and if you live in a village of say 500 people, you're probably related to most of them in some way. As you pointed out, in many cases there are still inherent weaknesses due to inbreeding. Whether or not that is a problem depends on the situation. Let's take a simple made-up example. Start with some sheep. These will be our base sheep. Let's say base sheep give 10 pounds of wool per year and live on average 10 years. So you get 100 pounds of wool per sheep over its lifetime. Next you breed some sheep. Super furry sheep. They give 15 points of wool per year. But their average lifespan is only 8 years. Is that a problem? Well, you are getting 120 pounds of wool every 8 years instead of 100 pounds every 10. Yes, the sheep are less healthy, but you get way more wool. If your primary goal is more wool, then that might be acceptable to you. Alternatively, you can be less selective with our breeding, allowing more genetic diversity, while still being somewhat selective for traits. It will probably take you longer to get the desired results, but you might be able to stave off the worst side effects of inbreeding. On top of that, with modern genetic testing, you can also be more selective about which breeding stock you use. If you can find some stock with beneficial traits that lacks likely negative ones, then you can be even more effective when you breed. Of course, that is probably a more expensive and slow process on its own. It all comes down to how much time and resources you're willing to invest versus what output you are valuing down the line. Humans did not invent selective breeding, ants did. Millions of years before H. sapiens appeared on the planet, ants and termites, and ambrosia beetles, at least that I know of. Leafcutter ants, for example, have been farming fungi for the last 50 million years or so. The cultivars found in their nests, which are thicker and provide more nutrients to the ants than spontaneous varieties, do not appear anywhere else in nature, and some cannot even survive on their own without the ants watering, fertilizing, weeding and cultivating their fungal gardens. They are quite clearly as artificially selected as much as an orange, a big red bell pepper, or a Fuji apple are. And it's not just fungi. It is estimated that ants assist in the dispersal of seeds for over 11,000 plant species, are in mutualistic relationships with at least 700 plant species, and engage in purely agricultural processes with hundreds of others. Regarding domesticated animals, More than 1,000 of the 4,000 known species of aphids and around 500 species of Lepidoptera are affected by and domestication. From Wikipedia, there is inbreeding, but you try to minimize it and or select away from undesired traits. With animals, you keep track of family trees and use a formula to calculate the inbreeding coefficient of potential matings. At the more expensive end, you can DNA test for carriers of undesirable traits, so you can get away with more inbreeding without getting bad traits or diseases. You can also outbreed now and then to bring some new genes into the mix. Some forms of livestock production also deliberately create crossbreeds for their resilience, e.g. breeder keeps stock of cattle types A and B, but sells AB cross progeny to farmers to raise, but not necessarily breed from.
Don't forget to like and subscribe so you don't miss our next exciting video.